Okay, so we had some questions about this problem right here. And mainly the concern was, well, how do we deal with these bearings? So what I've done is I've drawn a little bit bigger picture. And let me go ahead, and this is 500 here, and this is 720. Forgot to put those on there. But the problem says that they gave us a direction in terms of bearing from, we were going from Naples to Elgin, and they said the bearing was 316 degrees. Well, whenever they give you information like that, what you think about is this. If you're going from Naples to Elgin bearing, whatever, 316 degrees, think of Naples as being a point right here in the origin of this north, south, east, west axis. And start up here at north and do a clockwise rotation until you hit the path of the plane. Now, when you do that, in other words, you always start at north, do a clockwise rotation, and that right there is the 316 degrees they're talking about. Now, if you went all the way around, of course, that would be 360 degrees. But, you don't go all the way around. You got 360 minus 316, and that leaves 44 degrees. So 44 degrees goes right here. That's where they get that 44 degrees in the problem. See, right up here, 44 degrees. I don't know how it's focused, but anyway, that's 44 degrees right there. Now, the thing is, if that's 44 degrees, then if you do 90 minus 44, you get this angle right here, which is going to be 46. See, this angle 46. Now that's important because now you have a triangle and you have an angle, side, side. Now, what they're asking for though, let's think about what they're asking for with this problem. They say they want to find the bearing of the flight from Elgin to Canton. So here's Elgin. They want the bearing from here to here. In other words, so what I'm going to do is I'm going to make a point right here at Elgin, make an X, and put that at the origin of this north, south, east, west, and start here at north. What they want is this angle right here. They want that angle. Now, we know part of it. We know this part up here is 90 degrees. What I need to figure out is what this part is, and then I can use the law of sines to get this angle inside the triangle. But let's think about how we get this angle right here. Well, remember that if you have two parallel lines cut by transversal, there's some properties regarding the angles. The alternate interior angles are going to be congruent. The alternate exterior angles are going to be congruent. So we could talk about this angle being congruent to this one. In other words, we can use this idea to calculate what this angle is right here. So look what we have here. We have a parallel line and another parallel line. Up here we have this parallel line, but you can see that this right here, this angle right here, is going to be the same as this angle right here. See? They're alternate angles. So you have a parallel line here, a parallel line here. See that? Parallel line, and these are cut by transversal, so you got 46 here, 46 here. Now, what we got to do is we got to use the law of sines to find this angle, which is easy for us. And then the bearing is going to be this 90 degrees, add it to the 46, add it to this angle right here. And that's going to be our bearing. So I hope that's enough. Let me zoom in a little bit so you can see what I did there. Okay. So if you need any more help, let me know.